Hey guys, it is finally time to get out of that sequences and series unit and move on to functions and relations, which I think you all will like much better. Everybody seems to just hate the first unit, and then enjoy the next couple units. So we're going to move on to the very first lesson. And this one is just an introduction to functions. So nothing like super major. We're just going to talk about functions and what they are. So a relation is kind of it's just a set of points. All it is. A relation is a set of points or ordered pairs. And sometimes we show this in a table, like a T-table. Sometimes you'll see it in what's called a mapping. And I'll show you an example of that below. We may have a graph.
Teachers, please be sure to take your virtual attendance in each class and homeroom.
Hopefully you got that. And lastly, we might just show it as an equation. It's very generic. A relation is just a graph, a set of points, something like that. Now, a function is really what we're talking about, and a function is more specific. And so if it is a function, then when we look at all of the points that are on this relation or on this graph, if it's a function, that means that the x values don't repeat. So we don't have two or more of the same x value. Y value, it doesn't matter. We could have, all of the y's could be the same. But as long as all of the x's are different, that's when it's a function. So for example, we might have these points. And when we have like several different points, we put them in curly brackets. And so let's say I have the point, 0, 1. Let's say I have the point 5, 2, 6, 2. I can have the y values can repeat, that's okay. And let's see, -5, 7. That is a list of points, and since the x values do not repeat, my x's are 0, 5, 6, and -5, then it's a function. So, not a function, I'm just going to change one of those points to make it not a function. 0, 1, 5, 2, 6, 2, and let's say 5, 7. Not -5. This would not be a function because my x value is repeated. Determining if it's a function is pretty easy when you just have a list of numbers. Sometimes we have a graph. So let's say I'm going to graph something that looks like that. This would be considered a function because of something called the vertical line test. A vertical line, if you have parts of the graph that crosses a vertical line in more than one point, then that means those x values repeat. Because if it's a vertical line, those x values would be the same. And so it's hard to show in this kind of video, but let's see what I can do here. Here's my vertical line. And if I slide that all the way across, at no time does it hit more than one point. It's always going to hit only one point. So no x values repeat. Now let's do the same, but I'm going to give you an example where it's not a function. Oh, and what? That. So I'm basically doing the same graph, I'm just turning it sideways. And if I were to take this vertical line, there are several times where it's going to cross in more than one spot. Many of those times it crosses in 3 places. So that means it failed the vertical line test, so it's not a function. Yes, my line's a little crooked, but still the same thing. So we're going to look at some examples and determine if they are a function. So all I care about are the x values. So let's look. I have -1, 0, 4, and 6. Yes, this is a function because none of those numbers repeated. None of the x values. Number 2 is a table. And 7, 2, 0, -4. Yes, that is a function because none of those numbers repeated. I had 2 y values that repeated, but that doesn't matter. Number 3 is what we call a mapping. So I'm going to show you what these means in terms of points. So every time you have an arrow, that's a new point. So for example, I would have the point -4, 0, because the x was -4, the y, that arrow pointed to 0. -2, 3. And notice there's 2 arrows coming from the 5. So that means the 5 has a y value of 7, and the 5 has a y value of 9. So this time, the 5s are my x values, and they repeat. So no, it's not a function. All right, number 4. This is a graph, so think about the vertical line test, and since it's in this kind of graph, it's a little easier because there's lots of vertical lines on there. And notice they cross in 2 points, which I've circled. So no, this is not a function. This top point is the point -3, 1 and -3, -2. They have the same x value. Number 5. With mappings, a lot of times it just helps to write out the points. So 2, 7, 8 goes to 0, 13 to -4, and 17 goes to 7. So this one is yes, it's a function because none of those x values repeat. Number 6, this is a graph, so think about the vertical line test. Is there anywhere where a vertical line crosses in multiple spots? No. So that means that yes, it is a function. It passed the test. To pass the test and to be a function, you only hit 1 time. Number 7, think about the vertical line test. If this was my vertical line right here, it would fail the test because it hit in 2 spots. So no, it's not a function. Number 8, this one hits in 2 spots, lots of places. So no, it's not a function. It fails the vertical line test. So now we're going to start looking at functions as equations. And when we talk about functions, a lot of times you're not going to see it as y equals. F of x equals y. They're the same thing. So most of the time you'll see it as f of x equals 2x plus 7. It's just a different way to write it, but you need to remember that f of x equals y. And so x is our input. We plug a number in for x, and f of x is our output. It's the y value. So we're going to do some examples of evaluating functions. So you have the equation f of x equals 2x plus 7. And I'm telling you to find f of negative 3. Notice that letter, that variable that's in the parentheses is x. So negative 3 equals x. So I'm going to plug in a negative 3 where I see x. So f of negative 3 equals 1. So we're going to do some examples, and number 9 says f of negative 9. So I have two functions. I have f of x and g of x, and that's what we'll see that. We'll see f of x, g of x, h of x, k of x. It doesn't have to be f. That's just the more common one that you'll see. So f of negative 9, I'm going to replace this x with negative 9. So negative 5 times negative 9 minus 14. That's 45 minus 14. And really, you can do that in one step in your calculator. Is fine. 31. All right, number 10. This one is to find g of 0.4. So I'm going to use the other function, and I'm only replacing the x with 0.4. So negative, I'm going to put that 0.4 in parentheses, only the x, squared plus 9 times 0.4 minus 1. It's important that you only put that 0.4 just where the x is, and n in parentheses. And if you type that in your calculator, I think you get 2.44. Number 11. This one's different because in the past, the number that I was given is in the x spot. This time, it's set equal to. So I'm not plugging in 21 for x. I have to find the x. So with these types of questions where it says f of x equals 21, I know that f of x is negative 5x minus 14. And that equals 21. So these we have to solve equations. So if I add 14 to both sides, I get negative 5x equals 35. And then if I divide by negative 5, I get x equals negative 7. And number 12, same thing. F of x, negative 5x minus 14 equals negative 16.5. So I'm going to add 14 to both sides. That gives me negative 5x equals negative 2.5. And then if I divide by negative 5, I get x equals 0.5. Not too bad, as long as you kind of remember, sometimes you plug it in for x, sometimes you set it equal to. It depends on the way the question is worded. And if sometimes you just have to memorize. If it says f of x equals, I set it equal to. If it just says f of 5, I plug in 5. All right, one last thing. These are graphs. So number 13, when it says find f of 3, Remember, I told you that f of x equals y. They're the same. So f of 3 equals something. This means that my x is 3 because I replaced the x with 3. So I am going to find the point where x is 3. So this is x is 3, and I'm going to look for the point that has the x value of 3. That's right there. That point is the point 3, 5. So f of 3 equals 5. Because when the x is 3, the y value is 5. All right, so think back. F of x equals y. I don't have my x this time. I have the y. Because it still left x there. It gave me the outside number, which is y. So I want to know, what is the point when y is negative 4? And here's the y value of negative 4. So this is the point that has the y value of negative 4. It's the point 1, negative 4. So f of 1 equals negative 4. The x value is 1 when the y value is negative 4. Okay. All right, number 15 says find f of 0. So remember, f of x equals y. This time I am given the x and I want to know the y value. So when is x equal to 0? And a lot of you might get a little confused because there's two places where it's right on the axis. And some of you are going to get them mixed up. So if you are struggling with this, sometimes it helps just to write out all of the points. For example, this one that I'm writing by is the point 0, 3. This one is the point negative 4, 2. This one, negative 2, negative 3, 3, negative 2, and 5, 0. So a lot of times students like to get these two confused on a problem like this. But only one of them has the x value of 0. And that is the one towards the top. So when the x value is 0, the y value is 3. F of 0 equals 3. And the last one that we're going to do, number 16, is f of x equals negative 2. So it's giving me the y value. It's giving me a y value of negative 2. And it's asking for the x. So these are the same points. I've used the same graph for all of these. Well, not all of them. I've used the same graph for number 15 and 16. So I'm going to look back at where I wrote out the points in number 15. And I want to know which one has a y value of negative 2. And if I look at all of them, this is the one that has the y value of negative 2. So f of 3 equals negative 2. The x value is 3. If you have any questions on any of these problems that I did, please email me. Please let me know, and I will try to explain it. Have a great day.